Let me see if I can. Okay. So I'm going to do it off my slideshow. So this is about algebraic equations. So you have done some of this before. This is basically a recap with just some added questions of how, after learning everything from this year, how would you apply to these equations? Okay, so let's look at these two examples. So you're more than welcome to pause, take down the examples, and then I'm going to do it with you. So the key thing here is we're going to look at equations with our exponents. So you need to remember your exponential laws. So quickly, let's just jot them down. So if I have a to the power of n times a to the power of m, because my bases are the same, I know that I can add my exponents. Okay, if I've got a to the power of n over a to the power of m, then I minus my exponents, and always top minus bottom. If I've got a to the power of n to another power, then I multiply them. Okay, so those are just some of the few. So it's always good to just revise on your exponential laws. So we're going to apply them here. So if we can see with this first example, what I'm going to do is I'm going to first apply my exponential laws, and then I'll solve for x. So I know 2 to the power of x I leave as is. But then on this side, because my bases are the same, I can add the exponents. So it will be 3 plus 7. So this will be 2 to the power of x is equal to 2 to the power of 10. Now, since my bases are the same, I can just work with the exponents. Because the bases are the same, I can drop the bases and just work with my exponents. So x is equal to 10. Very important, the bases have to be the same here. Okay, let's look at the second example. So first things first, okay, we're going to use our exponential laws. So I'm going to, since these two bases are the same and they're multiplying, I can add my exponents. So it will be x plus 1 plus 5. Now on this side, because I want this base the same, so I want the 4 the same as the base 2, I need to think, how can I get 4 as a base 2? So I know if I go 2 to the power of 2, that's the same as 4. So I can change that 4 to 2 to the power of 2. And I just have to remember to bring down, to still keep that 4. Okay, what exponential law can I use on that side? So this one over here, I've got x plus 6. Then on this side, I've got 2 to the power of 2 to the power of 4. So I know when I raise it to a power, I need to multiply. So 2 times 4. So this is 2 to the power of x plus 6 equals 2 to the power of 8. Now, my bases are the same on both sides, so I can drop my base and just work with my exponents. I'm going to carry on this side. So I just go x plus 6 is equal to 8, all because I know my bases are the same. I take that 6 to the other side, and I get x is equal to 2. Okay, feel free to pause if you need. Let's look at this one, this slide here. Okay, so this one, we're going to keep in mind my exponential law that if I've got a to the power of n over a to the power of m, that I minus my exponents. Okay, so this one over here, my bases are the same, so I can see here, this 3 is the same as this 3. So I can apply my exponential law. So it will be 3, 2 minus x is equal to 3 to the power of 7. Are my bases the same on both sides of the equal sign? Yes. So now I can drop my base and I can just work with my exponent. Okay, I take the 2 to the other side and I get negative x is equal to 7 minus 2. So then negative x is equal to 5. Get rid of that negative and you get x is equal to negative 5. Okay, let's look at this example here. Given y is equal to 4x squared plus 1, complete the table below. Okay, so this is with your functions, right? So if my input is negative 3, what will my output be? So I know y is equal to y is equal to 4. Now instead of x, I'm going to put negative 3 squared plus 1. Okay, so that would be 4 times 9 plus 1, which would be 36 plus 1 is 37. Okay, then I would put in negative 1. Right? So then it would be 4 times 1 plus 1. That would be 5. Then if I put in 0, so 4 times 0 squared plus 1, that would just be 1. If I put in 1, that would be 4 times 1 squared plus 1, that would be 5. Okay? Now it says list 2 other ordered pairs for the equation. Now ordered pairs just mean your outputs and your inputs. Okay? So an ordered pair would be 1 and 5. I put in 1 and I got out 5. Okay? Another one would be 0 and 1. So it's always your your input, your input and your output. Okay? So other ones could be if I put in 2. So 4 times 2 squared, which is 4 times 4 is 16, plus 1 is 17. So if I put in 2, I got 17. If I put in 3, so 4 times 9 plus 1, that would give me 37. So 3 and 37. Those are ordered pairs. Okay, your input and then your output. Now it says, given x is equal to negative 8, find the ordered pair that satisfies the equation. Okay, so they're just giving you your input and they want to know what your output would be and then to put in an ordered pair. So y is equal to 4 times negative 8 squared plus 1. That would be 4 times, okay, so you've got your 8 squared, which is 64. 4 times 64 plus 1, so you would use a calculator and you would get 257. So this ordered pair would be negative 8 and 257. So again, your input and then your output. Okay. All right, I will list your homework on Teams, what you need to do for this section.